Well, hello, I'm Professor Jim Hoover. We'll review some basic IT to give you some background to better understand the healthcare informatics environment. We'll cover some basic technology definitions. They are the building blocks of all healthcare IT systems. And let's start off with algorithms. The concept has been around since Babylonia was the center of all of the world, about 2500 BC. It basically describes how to solve a problem in math or computer science. Think of it like a recipe. A recipe tells you how to bake a cake, it gives you a list of ingredients, and in the same way, an algorithm uses data to make something with a computer, some kind of output. Every healthcare system has an algorithm inside of it. You can think of the most basic things like computing a patient's age. You do this by taking the current year, subtracting their birth year, and then taking into account whether or not the birthday has passed or not. And in this way, you can derive what age the patient is. That is an algorithm. We are living in an age of big data. In fact, so much so, a 2017 article in The Economist stated that the world's most valuable resource is no longer oil, it's data. Big data encompasses the techniques and technologies used to process data at scale. And typically we're talking about a way to systematically transform and extract the data to do some processing analytics based on the values of the data. The amount of data that is being produced is growing rapidly. Many have measured 23% year upon year. Some estimated that it's 79 zettabytes. And that's a 10 followed by 21 zeros. When we talk about big data specifically, we refer to it as the 5 V's. The volume of the data, how much data are we actually receiving? The velocity, how fast is that data coming into our system, and how fast can that data be processed? We also consider the variety of the data, the sources. Where is it coming from? Is it patient-generated data coming off of their Fitbits, their watches, their phones? The veracity of the data speaks to the quality of the data. Is it clean, accurate? Do we know its provenance? We talk about the value. Are we transforming this data into information about the patient? And those are the big data 5 V's. Now, I'm sure everyone has heard about cloud computing, providing computing resources over the internet. And this is really what's called on-demand computing, where we can scale systems horizontally or vertically. Horizontal scaling simply means adding more computers as we need to do more processing. Vendor provides these computing resources on your behalf. They purchase the hardware, they maintain it, they upgrade it, they secure it. They also reduce their IT staff. In many ways, this is reminiscent of early computing actually, where we had big mainframes and we did something called time sharing. And by the way, internet is always capital I. Always. It's a place. Computer programs are instructions. It's how we inform the computer on what to make. Computer programs are usually written in one, but sometimes more than one, computer language. And every computer program implements a specific algorithm to solve a specific problem. Sometimes we call computer programs software, applications, or even just programs. And these programs might include data that's involved to configure the application or customize the software. For example, we may have information about the internationalization, what font, what language should we display the help text in, custom workflow, or users might set their own color scheme. A data structure is a computer science term that determines how data is organized inside a computer program. For example, a patient data structure might include things like fields for the first name, the last name, the middle name, the address, the patient's birth date. Databases are highly organized for efficient storage and retrieval of data. Computer programs and humans can actually access databases via a special computer program, database management system. First, real databases were hierarchical and very rigid. Later, relational databases came around, allowed a lot more flexibility. Later on, specialized databases, and that includes object-oriented databases in the 90s, graph databases as well, and most recently, NoSQL databases. They're very flexible, store documents, and they tend to be very popular for data scientists. Programming languages. These are tools that describe an algorithm to the computer as a sequence of instructions that tell the computer what to do. There are a few computer languages used in healthcare informatics that I at least want to make you aware of. Python is a very powerful tool, but it's easy for novices to pick up and get started. Easy in quotes. Programming is not easy. R is another programming language that's very popular for statistical computing, and everyone knows this language, HTML, and is called a markup language because it describes how you want text to appear on a web page. Mentioned SQL earlier, SQL. That stands for Structured Query Language, and that's used to query, update, insert, and delete data from these databases. Our industry has been a very slow adopter of technology. I define healthcare informatics as the study of computational healthcare. It's a multidiscipline field that encompasses computer science, data science, healthcare information management, and medicine to improve patient outcomes. All of us have probably used something built on MUMPS, really a relic of when computers were first created. It combines the data and the programming language into one space. MUMPS uses a hierarchical data storage system, not relational, so the information does tend to be fixed and it's harder to modify. And MUMPS has developed into a proprietary language and database system called Cache, and it's still in very large EHRs like the Veterans Administration Vista, inside of Meditech, Epic, GE Centricity, and I think even Allscripts. That's your history lesson for today. Please feel free to reach out to me with any questions that you have. You can get me at jhoover@charteroak.edu, or you can use artofpatientmatching@gmail.com. LinkedIn is always great. Love to have more connections. Like the video, subscribe. You never know what else I'm going to post. Thank you so much. Have a great day.